Hello, this is Tyler Beamer, Haywood Community College. It's an instructional math video for DMA 040. This video is in regards to Module 4, Section 5, Multiplication Property of Equality. Alright, so essentially the multiplication property of equality states that if you have two expressions that are equivalent, if you multiply both sides of that equation by the exact same number, then the resulting expressions are still equivalent, or if you divide both sides of that equation by the same number, the resulting expressions are also equivalent. Okay, so once again, keep in mind the idea of balancing scales, right? Want to keep that equation balanced. You know, whatever I do to one side of the equation, I got to do the exact same thing to the other side of the equation. So that's essentially what this is saying. Alright, so let's look at some examples here. Negative 4x equals 16. Solve for x. So keep in mind once again that we want to try to get that x equals statement. That makes this a solution, gives us a true statement there for the equation. So in this case, I have negative 4 times x. So the opposite of multiplication would be division. Division undoes multiplication. So if I divide both sides by the exact same number that I have here, that gives me a 1x, or x. Okay. And then using the multiplication property of equality, whatever I do to one side of the equation, I got to do to the other side, keep it balanced. 16 divided by negative 4 gives me negative 4. Okay, and then once again, we can check that solution. Plug a negative 4 in for x. Negative 4 times negative 4 is a positive 16. 16 equals 16. That is a true statement. Therefore, we would have the correct solution. Okay. Equations involving fractions. Okay. So I want to get rid of the 3/5, and this is 3/5 times a. Okay, so we could divide by 3/5. We could do this and divide 3/5 to the other side. And 3/5 divided by 3/5 is a. But this is what we call a complex fraction. So this is equivalent to 12 divided by 3/5. And 12 can be written as 12 over 1. And to divide fractions, I essentially multiply by the reciprocal. And the reciprocal is this fraction flipped. So the numerator becomes the denominator and vice versa. Then I can multiply. 12 times 5 is 60. 1 times 3 is 3. 60 divided by 3 gives me 20. And so that would be the value of a. Now that's a lot of work to get to our solution. Here's a shortcut. Okay. If I have 3/5 a, or any fraction times the variable, to get rid of this fraction, just multiply both sides by the reciprocal, right, which is the reversal of that fraction. So 5/3 times 3/5, that gives me 1a. Do the same thing to the other side. Notice I still get 60 over 3, which is equal to 20. So I get the exact same answer. This is more efficient, right? Because we're basically doing this problem in one step, right? As opposed to writing complex fractions, dividing fractions, in which we're going to end up multiplying by the reciprocal either way. So we're just kind of bypassing all of this and going straight to this step right here. Okay. Sorry about that. There we go. Had a paper with some writing on it. So this is the same type of problem. 1/7 x equals 5/9. Okay. So once again, to get rid of the 1/7, multiply both sides by the reciprocal, which is 7/1. This gives me x, right? Then I multiply across the numerator, the denominator, and get 35/9. If I could reduce this, I would want to do that, but this is an improper fraction that cannot be reduced, so we'll keep that in that improper form. Okay. So once again, remember to simplify first. So notice I've got a lot of simplifying here. I've got like terms of 12x and 8x, which gives me 20x, and then 30 minus 6 gives me 24. So I get 30x plus 24 equals 10. So now I can start the solving process. So I want to work to isolate x. If you have adding and subtracting inverses and multiplying and dividing inverses in the same problem like this one, work with the adding and subtracting first, right? Always do those inverses first. So let's subtract the 24 from both sides. Get that out of the way. Sorry. And so that gives me negative 14. Then I do the dividing and multiplying inverses last. So the multiplying dividing inverses is going to be generally the last thing that I do in the problem. So since this is 30 times x, I'm going to divide both sides by 30. X equals negative 14 over 30. 30 is not going to divide into 14. However, that is a fraction that I can simplify. Both sides are divisible by 2. So I can divide 14 by 7 and get 14 by 2 and get negative 7. I can divide 30 by 2 and get 15. So x would equal negative 7 over 15. So essentially this got divided by 2 and then this got divided by 2. Okay. Alright. It's another similar problem. Okay, so start out by simplifying so I can distribute here. On the left, 10x plus 15. Got like terms on the right that I can combine. Okay, so then like I said, work with your adding and subtracting inverses first. So I want to get rid of the plus 15, so I want to minus the 15. Okay, that's going to help me to isolate x. So those cancel, gives me 10x. 6 minus 15, right? That's going to give us a negative 9. Okay, and then we can then divide both sides by 10, since this is 10 times x. So this gives me a 1x. And then 10 is not going to divide into negative 9, so I would write that as a fraction. X equals negative 9/10. Okay, so that should give us all of the properties that we need to solve equations. Those are the adding, subtracting inverses, and the addition property of equality, the multiplying, dividing inverses, and the multiplication property of equality. And then we will continue to build upon those in future modules. All right. So if you have any questions, please email those to me or stop by the office. Have a great day.